indirect measure. Indirect measure allows you to use properties of similar polygons to find distances or lengths that are difficult to measure directly. Everybody agree with me, we couldn't just walk outside and measure the goalpost. Agreed? Way too tall. But today we're going to talk about how through indirect measure we are going to be able, not going directly to it, but through another channel, we're going to be able to figure out how tall that football goalpost is. So all of this depends on angle-angle similarity. We talked about similarity last week. And so we need to expand on that further. We would always say, oh, they're similar, they're the same shape. Well, today we're going to talk specifically with triangles. And the way we can prove that the triangles are the same shape, the same looking triangle, is through angle-angle similarity. The rule states, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. If you can prove to me that two angles from the left triangle are equal to two angles in the right triangle, I'm going to know these are similar. That's what the rule states. Now let's talk about why the rule states that. Everybody see that they said A has one swoop on it and F has one swoop. So A and F are congruent. There's one pair of angles that are congruent. B has two swoops and G has two swoops. There's my second pair. The rule states because of that, I know my angle or my triangles are similar, which means that C and H have to be congruent. My question is, how can you prove that to me? What information have we learned previously this year that you can guarantee me, because of this rule, Miss Hoff, I know that C and H are the same? Gallon? That doesn't, but your dilation doesn't change your angles. I'm trying to determine or prove that I know C and H are equal. How can you guarantee me C and H are equal? Lane? But that tells us that we don't know anything about them. Good observation. Gabriel?
Should both equal a number minus 180 or 180 minus that number. They both
Very perfect. The thing that we have to go back to is all triangles equal 180, right? Now, if A and F are equal and B and G are equal, when I add them together, it's going to be the same amount, yes? So whatever that amount is, let's call it P. If I take 180 minus P for this triangle, I'm going to get C, right? And if I take 180 minus P for this triangle, I'm going to get H. Well, 180 minus P and 180 minus P should be the same, agreed? So because we know that those two are the same, when we add them together, they're going to be the same. And we know, like Gabriel just told us, all triangles equal 180. So therefore, that third measurement to get us to 180 would have to be the same. Awesome job. Now, am I going to say on your test, please prove to me how you know that the third, I'm not asking you that, but I want you to understand why we know what we do. Today, we're also going to deal with similarity statements. We're going to have to write a similarity statement. Remember, similarity is that tilde, that squiggle. And just like when we wrote the congruent statements back in 7.2, order matters. Order matters. So make sure we pay attention to the order of our letters. So first off, they just want us to like, hey, here's some triangles. Determine whether or not they are similar. And yesterday and last week, we talked about, oh yeah, they're similar. They're the same shape. Well, now I have to prove that they're the same shape based off my angles. I need to prove two angles in G, or in this triangle, match two angles in this triangle. So they walk us through. Angle blank and angle blank have the same measure, so they are blank. Joel? Joel. What am I talking about? Jacob, I put your first name and last name together. Angle A and angle E are the same measure, so they are congruent. Nicely done. I'm going to put one swoop on them just so that I have those markings. Okay. Then it says angle blank and angle blank measure 70 degrees. Tori? How do you know G is 70? I understand why you say C, because it says 70. How do you know G is 70? Okay, so if we take 62 plus 48, the other two angles, what do I get when I add those together? 110. Then what should I do with that? We don't know it's 70. Take 180 minus 110, which would give us 70, proving that G is 70 degrees. Okay? So angle G and C measure 70 degrees. And here's the deal. You got to check because they're going to trick you sometimes and they're not going to be the same. So because I have E and A, one pair, and then G and C, a second pair, so two angles of EFG are congruent to two angles of ABC. So this is where we write our similarity statement. Triangle GFE is similar to, you write the other three. Put them in the correct order. Don't say it out loud. I say GFE is similar to triangle CBA. Okay, so just to double check you, G and C are congruent, F and B are congruent, E and A are congruent. Nicely done. Now remember, I could write triangle FEG. That's okay, as long as on the other side I write triangle BAC. That. What do you mean?
Like if we were to write out what's similar and we don't write, like we don't.
You have to write that similarity statement. You were thinking like angle G equals angle C. No, this is the similarity statement that you want to write. Yes. No, I just wanted to show you that like if you write it in a different order here, as long as you follow in suit, I'll still give you credit for it. No, you don't have to write all the options down. No. Question.
Do we need to have a triangle?
Yes, because it's a triangle. Yep, you got to have a triangle. Okay, so let's try it again. Different drawing. Determine whether the triangles are similar. If so, write a similarity statement. First off, do you see the two triangles? You got this guy here and this guy here, yes? Somebody who has an answer for me. Get me started on this. I need to prove that two angles in the yellow triangle match two angles in the blue triangle. Isaiah? L and H. How do you know? They tell us they're 110. It clearly states 110. Nicely done. I know angle H is congruent to angle L. And this is, I'm going to write notes like Thad was just talking about, just so that when you go to write this or do this later on your own, you're like, gosh, I don't know what I did here. He's absolutely right. We know that because they gave us 110. Now, the only way I can prove that these triangles are similar is saying that I have another angle in the yellow one that matches an angle in the blue one. Casey?
J and M because K is for both of those, they're vertical angles.
Okay, back up. Actually, the second thing you said is what I want you to tell me. Tell me about K.
K is for both of those angles on the yellow and the blue, and then same because they're vertical.
Remember vertical angles? They share that vertex and go in opposite directions, right? They share that vertex and go in opposite directions. So angle K is congruent to angle K. Write that down because of vertical angles. Then what she said is, well, if we know these are 110 and who cares what number K is, they're equal, we have to know that J and M are. So are these triangles similar? Yes, they are similar. Triangle KJH is similar to triangle, don't say it out loud, you write it down. KJH is similar to triangle KML. K matches K, J matches M, H matches L. So this is like, for me, just so you can see your work, you know what I mean? So you can look back at it later. What I'm really looking for is this piece here. Okay, cool, Miss Off. We've talked about this word similar for like a million days. I thought we were talking something new today. So let's get into what indirect measure actually means. One type of indirect measurement is called shadow reckoning. Two objects and their shadows form two sides of right triangles. Shadow reckoning, and they form right triangles. I'm going to draw you a picture up here. Okay? In order to have a shadow, you got to have the sun in the sky, right? If I go outside, the sun is out right now, and stand there, a shadow is formed on the ground in front of me, correct? If I connected the top of my real head to the top of my shadow's head, I would form a right triangle. Yes? Now, anything that's standing next to me, whether it's a dog, whether it's a tree, whether it's the bleachers, whether it's a building, is next to me, it also has a shadow on the ground. If you connect the top of that to the top of the shadow on the ground, it's a right triangle. Everybody see how we come up with the two right triangles?
Yes.
Now, in order to use shadow reckoning, though, we have to have triangles that are similar. The rule of similar says we have to have two angles. Well, I only have one. And I'm going to explain to you, if we're standing next to each other outside and the sun is beating down on the back of our head to form that triangle, everybody agree that it's hitting us at the same angle, whether it's me or a dog or a tree? So technically, the angle of the sun up in the top are also equal. And that seems kind of weird, but that's how, if you want to talk about, like, that's where the second angle comes, so you have similar triangles. Again, am I going to say to you, please show me why shadow reckoning works? No, but understanding will help you process it more. So since two pairs of corresponding angles are congruent, the two right triangles are similar. So this is where we're actually going to reach back into 7-4, our book assignment, where we could take two similar polygons and we could find that missing side length. So in the figure, DBA is triangle DBA is similar to triangle ECA, and Raymond wants to know the distance across the lake. Again, I say to you, when I look at this, do you see two separate triangles? I would strongly encourage you to draw them separately. They even help us out. Triangle DBA, DBA. So if I draw this triangle here, somebody who hasn't answered for me, tell me important information from our original diagram that I probably should put in my new little triangle I drew. Tori? 320 meters, very good. Anything else? 40 meters, the right angle. There's one other thing. Yeah, you see the swoop on the A right there? They talk about triangle ECA. Draw that one out. Somebody else tell me, what should I pull from my picture to put in the little triangle that I just drew that's important? Tori helped us out on the last one. She brought the 320, the 40, the 90, and the swoop. Paxton? 162. Thoughts? Maddie? How'd you come up with that? Be careful. I like that you noticed that 162, Paxton, but be careful. That's only from B to C, and we actually need that whole piece. So nicely done. Maddie added together 482, you said, right? Okay, 482. What else? The right angle. Jacob? The swoop in the A. And the D, because that's what he really wants to know. He wants to know the distance across the lake. Okay, ignore everything else we've talked about today. This is just like 7-4 book assignment. Take your two shapes. Find two sides, one from the left triangle, one from the right triangle, that are both numbers. Sides. Take a side from the left triangle and a side from the right triangle that match up that are both numbers. 320 and 482. 482 equals, is she right? If she's right, she's telling me that 320 and 40 came from the same triangle, and 482 and D came from the same triangle. Did she set that up correctly? Yes. Nicely done, Peyton. Now what do I do? Okay, everybody listening? Is everybody listening? Have I divided anything yet? People started doing weird division things, and then you don't know what you're supposed to do with that number. Cross, multiply, butterfly. But show your work. Don't be lazy. What I mean by showing your work is write out 320 times D equals 482 times 40. What's 320 times D? 320D. What's 482 times 40? 19,280. Okay. Now what do I do? Divide by 320. D equals 60.25. Can I have a decimal? Yes. Now, if it's a long, crazy, carrying on, irrational decimal, should you panic? Yes. Okay, if it's going to be a decimal, it's going to be nice and easy. Technically, what label would I put on 60.25? Meters. Meters. Here's what I'm telling you. The people that are frustrated with their quiz and today is because they're skipping this. And they're dividing and trying to, like, do I multiply or do I divide, Miss Hawk? You shouldn't have to guess. If you set up that cross multiplication, you use the butterfly, you'll know exactly what you're supposed to do. What happens if they don't give us a picture? You use Miss Hoff's art skills. Eduardo is 6 feet tall, casts a 12-foot shadow. At the same time, Diane casts an 11-foot shadow. How tall is Diane? Meet Eduardo. Eduardo is 6 feet tall. I know from his head to his toes is 6 feet. His shadow is 12 foot long. On the ground is 12 foot long. Put your calculator down. You're drawing a picture with me. If I connect the top of his head to the top of the shadow, I form a right triangle. Then there's Diane. Oh, Diane. There's Diane. How tall is Diane? We don't know. Can we call her X? How long is her shadow? 11. We connect them. We have a right triangle. Pick a number from the red one that matches with the number on the blue one. 12 and 11. 12 is to 11 as 6 over x question mark. Tori's not quite sure, but she thinks. 12 and 6 are from the same triangle. 11 and x are from the same triangle. Yeah, nicely done. Cross multiply on your own, showing the work, and tell me how tall Diane actually is. How tall is Diane? 5.5, and technically my label would be 5.5 feet. Question?
Do you want us to I did 5.6?
Just leave it as 5.5. Yep. I totally understand what you did, but no, I'm not going to get that picky on you. Okay? One more. Find the distance from the house to the street light. Everybody see that we're trying to find the length of D? This looks like a picture from 7.4 the other day when we used all the shapes to match up the numbers. Remember doing that? So if I put a square around 8 meters, 8 is between 2 swoops on X and 1 swoop on T. What does 8 match up with? 4. D. D is between 2 swoops on X and Z. What does D match up with? 5. Set up the proportion, cross multiply, and solve on your own. Determine for me how far is that house from the street light. Ten? Did you get 10? 10, what would your label be? Meters. Meters. Okay? All right. Their homework starts off with determine whether or not they are similar. If they are, write the similarity statement. If not, just write not similar. Then it's going to go into exactly the last 3 problems we did. I created a Google form for you to check your answers as you go. Yes? This is what I'm going to ask of you. Please get your device out and log into it. Don't open anything. Just get logged in to let me see your desktop. Okay? Then you can use it to check in just a minute. I'll tell you when. Use it to check your work. If you get them all right and done before the end of the hour, you're welcome to work on other homework. Please do not make me ask you to sit and be quiet. Are you absolutely going to turn to your neighbor and maybe ask them what they got? 100%. But please don't have social hour. What I'm going to do